All right, so let's take a look at today's lesson. So today's lesson has got some topics that we talked about and learned last year in Algebra 2 Honors. What we're going to do is we're going to look at several. Some of this will be new, but some of it will be, previous, what you've already learned. So let's start with the fundamental theorem of algebra. That sounds really important, right? Fundamental theorem of algebra. It is kind of important. So let me talk about what each part of this means. So for the first little bullet point, every polynomial of an n degree, as long as n is bigger than or equal to 1, has exactly n zeros. What does that mean? So for example, let's say that I had f of x was, x to the fourth plus 3x cubed plus 1, something like that. I don't know. What does this theorem tell me? This theorem tells me that my degree, the degree, if you recall, is the highest exponent, and the highest exponent is a 4. That means, what that means is that I am going to have 4 zeros. That's what it means. It tells me how many answers I'm going to have. So that's what the first bullet point is talking about. The second bullet point says if the complex number z is a 0 of p, then its complex conjugate is also a 0. We looked at this last year. Recall, let's remember if one of our solutions was, say, 2 plus I, then we knew that there was a second solution, right? Do you remember when we did that? 2 plus I, then the second one would have been 2 minus I. So the conjugate, remember, complex answers or imaginary answers always come in pairs. They're always in pairs. If 2 plus I is a solution, then 2 minus I is a solution, and so forth. Okay, hopefully that rings some reminding bells there. All right, then the last one, it says every polynomial can be factored into a product of linear and irreducible quadratic factors. Now, these are vocabulary words, so let's talk about a linear factor. What in the world is a linear factor? This is an example of a linear factor. Okay, why is that factor linear? Because x is to the first power. That's why it's linear. Remember, equations of lines have x to the first power. They're called linear. So every polynomial can be factored into a product of linear, which looks like that, and irreducible quadratic factors. Another vocabulary word, irreducible. So this is an example of an irreducible quadratic factor, x squared plus 1. That is irreducible. Why? Because if I were to try to, solve it, so let's just look here. If I did x squared plus 1 is 0, and I got x squared is negative 1, then remember when I square root both sides, I'd have an imaginary number. X would be plus or minus I. That's why it's irreducible, because if I kept going, it would create imaginary answers. That's what it means by irreducible. If you keep going, you produce imaginaries. And so that's the third bullet point of our fundamental theorem of algebra. Any questions on that first block? Okay. Let's look at our next two theorems. We've got the remainder theorem. So what does this tell us? It tells us, and your textbook actually asks you to use the remainder theorem and the factor theorem. So what is it? So if the function is divided by x minus c, so you could do it synthetically, or you could do it, so the dividing, we have two ways. We have synthetic division, which is normally what we would use for remainder theorem, and we have long division. Those are our two options. which we did cover both of those options last year. If you don't recall, you might want to go take a glance at it. Then the remainder is f of c. That's what the theorem tells us. If you divide it all out, the remainder that you get would be f of c. The factor theorem tells us that if f is a polynomial, then x minus c is called a factor of f, if and only if. So our little fancy notation in math, we usually put IFF for if and only if. If and only if our f of c, which is the remainder, only if the remainder is 0. That's what tells us if x minus c is a factor, is if the remainder is 0. So when you're doing long division and you get or you're doing synthetic division or long division, either one, and you get a remainder of 0, then you know that you divided by a factor of the function. All right. Any questions on that block? Okay. Let's look at the next block. Rational roots theorem. Ooh, does that ring any bells? P over Q? Or have we successfully blocked it? Does that bring joy or terror? Either one? Or just we successfully blocked it and we have no idea what I'm talking about? Successfully blocked. I mean, that can happen when it's terrifying, right? P over Q is where we're using synthetic division, checking all different kinds of answers or factors, zeros. Okay, that's okay. Well, we'll just have to remember it again. It'll be fine. So if a polynomial has a rational root, okay, there's a vocabulary word. What does rational mean? Rational mean the kind of numbers. Rationals are integers and fractions. That's what rational roots are. Irrational, remember irrational are like square roots. And imaginary are the i's. This theorem only works on integer and fractional roots. That's it. It does not work on irrational or imaginary. So how does it work? Okay, so we make a fraction, p over q. P is the constant and Q is the leading coefficient, and it's plus or minus P over Q, and those are all the possible rational roots. And there, you may or may not remember, but you will. Okay, so that's rational root theorem. We also are looking at Descartes' rule of signs. Descartes' rule of signs basically just tells us, it's kind of nice, it's kind of like a guiding theorem or rule. It tells us that the number of positive real zeros is going to be equal to the number of sign changes. Variations in signs means sign changes. The number of sign changes or is less than that number by an even whole number, which is usually what drives students crazy, but I'll talk about that when we get to the example. Then the number of negative real zeros is going to be equal to the number of variations or sign changes of p of negative x, or is less than that by an even whole number. And I'll get that explanation when we do the problem. So that's the rule. Okay, that's the rule. How we doing? Okay. So let's look at the other side of this information page. So this is just vocabulary right here. So if we divide polynomials, which, you know, dividing two polynomials actually is a rational function. We're putting those together. So if we divide two polynomials, then, like, I'll put it over here. So if we do f of x divided by p of x, these, again, just vocabulary words. This is called, f of x is called the dividend, and p of x is called the divisor, and then r is our remainder. R of x is our remainder. And when we divide them, we get something called the quotient. And when we write our remainder, it's the remainder over the divisor. That's just the format of how things would look if we're doing long division. Okay, so just some vocabulary words. All right, the last part, the last block we're going to look at is the intermediate value theorem, which is actually really important in calculus. This is important in calculus. We cover this theorem in calculus. So, think back to your time in geometry about theorems. Remember, in geometry, there's a hypothesis and a conclusion. Remember all that business? Hypothesis and conclusion? Same thing with calculus theorems. So there's a hypothesis. The hypothesis is the if. This is the hypothesis. And there are 3 points of this hypothesis. There's a 1, and a 2, and a 3. If these 3 things are true, then this is our conclusion. So if f is continuous on the closed interval, if f of a is not equal to f of b, and if k is between f of a and f of b, okay, so let's make ourselves a note here. K is a y value, and c is an x value. That's usually the most confusing thing that students have, is the difference between k and c. K is a y value, c is an x value. Our conclusion, if all that stuff is true, if k is between f of a and f of b, and all the other 2 things are true, then there exists a number c, which is an x value, between a and b, for which f of c equals k. So that's a lot of words. I'm going to draw you a picture which explains and shows you what all that means, because that's a lot of mathy words. Okay, so help me, stay with me. We're going to draw a picture. Okay, so we've got this graph. This is like A, and this is like B. Okay, and we've got some function, I don't know. It could be any kind of function. I just scribbled something there. It doesn't matter. Any kind of function. Okay, that's f. So right above a, the y value above a would be f of a. And the y value above b would be f of b. Okay, so let's go through our 3 parts. So number 1, the first bullet point, f is continuous between a and b. Those are x values. Check. It's all continuous. Second, f of a does not equal f of b. So let's investigate that. So f of b is this height, right? That y value. And f of a is down here. They do not have the same y value, right? One is down lower than the other one. That is true. F of a does not equal f of b. Okay, great. Okay. K, so I'm going to mark K. Let's just say this is K. Is K between f of a and f of b? is it between f of a and f of b? Is the y value k between the y value of f of a and the y value of f of b? Yes. So part 3, yes, k is between f of a and f of b. Great. Then what? Then there exists a c value. Here's my c value. My c value is between a and b. It's between a and b. Then there exists a c value for which f of c equals k. That's what the theorem guarantees us. If those 3 things are true that I just bulleted, then we are assured that there will be an x value c for which f of c equals that y value of k. Okay? It's the intermediate value theorem. It's saying that there is a value in between those y values. All right. And I will show you how we're going to use it in this course. Is we're going to use intermediate value theorem to find a 0. But I'll get to that problem in just a moment. All right, any questions so far on our information page? You're probably already like, what? That's a lot. It's a lot of remembering. Some of it is reminder, right? We did fundamental theorem last year. We did remainder theorem last year, factor theorem last year, rational roots theorem. All that was last year. We divided last year. The only new things this year are Descartes and intermediate value theorem. The rest of it is a review. So let's jump in. So let's start with Descartes. That's the new one. We're going to use Descartes' rule of signs to determine how many positive and how many negative zeros a polynomial can have. Okay, great. So here we go. So what do? I'm looking for sign changes. I look at p of x. I look at this number and this number. I'm looking there, right? I'm looking for sign change. I went from a positive 3 to a negative 4. So this is one sign change. I'm going to put a 1 there. There's 1 there. Okay, great. There's one sign change. So now I'm looking for a negative 4 to a positive 3. Okay, great. That is a second sign change. There's a second one. I look from the positive 3 to the positive 2. Yeah, there's no sign change there. But I do have a sign change right here between the positive 2 and the negative 1. That's my third sign change. Between the negative x and the negative 3, there is no sign change. So the total number of positive real zeros is going to be either 3 or I have to subtract 2 from 3 until I get down to nothing. 3 or 1. Now I'm going to do a little aside up here. What if, this is an example, what if I had 6 possible positives? What if I had 6? Then I would have 6 or 4 or 2 or 0. I have to keep going until I get to a 0 or 1. Why? Why am I doing that? I'm doing that because when it is defining them as positive, the total number of positive zeros, those could also be imaginary. So I could have 6 positive real zeros, or I could have 4 positive real zeros with 2 being imaginary, or I could have 2 positive real zeros with 4 being imaginary, or all 6 could be imaginary. So why is it minus 2 every time? Because of imaginary. You don't really have to know that. I just find that if you kind of understand why the rule is there, maybe you will remember it. All right, so that's total positive ones. Now let's work on possible negative ones. To do that, we have to find p of negative x. That's what we have to do. So to find p of negative x, I'm going to have to plug in a negative x everywhere there's an x. So 3 times negative x to the 7th minus 4 times negative x to the 4th plus 3 times negative x cubed plus 2 times negative x squared minus negative x minus 3. Okay, great. That's p of negative x. Now I need to clean it up. Got to clean it up or we won't make any sense. If I raise a negative x to an odd power, I get a negative number, right? That's the way that works. So this is going to give me negative 3x to the 7th. I raise a negative x to 4, which is an even number. Gives me, that would be positive, so this would stay negative 4x to the 4th. I raise a negative 3 to the 3rd. I get a negative number, so negative 3x cubed. I raise a negative x squared. That gets rid of it, so plus 2x squared. Minus a minus 3 is a, minus a minus x is a plus x, minus 3. Now, just like when we were looking for positives, when we're looking for negatives, I'm comparing term by term. I'm comparing these terms right here, all these terms. I'm looking at the comparison of those terms. Okay, when I go from a negative 3 to a negative 5, I do not have a sign change. When I go from a negative 4 to a negative 3, I do not have a sign change. When I go from a negative 3 to a 2, there we go, that's one sign change. When I go from a 2 to a 1, no sign change. When I go from a positive 1 to a negative 3, oh, there's another sign change. So there's 2. Okay, so number negative are going to be 2 or 0. Okay. Now we want, then it says then determine possible total number of real zeros. Okay, so first of all, this is the only option for positive ones, and this is the only option for negative ones. That's it. There's nothing else. So I have to combine the positive and negative to figure out how many total. So what do? Well, I'm going to put the 3 with the 2, and that gives, so this is total number. 3 with the 2 gives me 5, or 3 plus 0 gives me 3. Okay? 1 plus 2 gives me 3, and I already have 3 written there. 1 plus 0 gives me 1. That's my total. And this was very confusing to students earlier, which I can certainly come by and help you with that. I'm hoping this what if will help with the total possible, positive, negative, but I will also help you. This is just a little rule. It's just a helper rule. Why might we use it? Well, you might use it on problems like number 2. Do you have to? No, not at all. It might help us determine how many positive and how many negative, zeros we could have. Again, it's just a rule, a helper rule. Okay. Questions? Okay, number 2, we're using rational roots theorem, P over Q. There we go with our lovely P over Q. So P, let's just make we're going to point to it. So this number is P, and this number is Q. The constant is P, the leading coefficient is Q. We need all the factors of P and all the factors of Q, and then we put them, make a fraction out of them. So I'm going to remind you Oh, I love the rainbow method for finding factors. So if we're finding factors of 12, I would do 1 times 12. Maybe you remember me doing that last year. 2. Is 2 a factor? Yep. 2 times 6. There we go. Does 3 go into 12? Yeah. 3 times 4. And then we know there's nothing in between them. So the factors of 12 would be 1, 2, 3, 4, 6, and 12. Just a reminder on finding factors. So in this problem, the factors of P are plus or minus 1, 2, and 4. The factors of Q are plus or minus 1 and 2. Okay, great. Now we need to find P over Q. Plus or minus. So what do? I take P and I put it in the fraction 1 over 1 and 1 over 2. That's what I do. And I do that with each of the numbers. 1 over 1 is 1. 1 over 2 is 1/2. Then I take the 2. 2 over 1 is 2. 2 over 2 is 1. Well, I already have 1. I don't need to write it again. Then I take the 4. 4 over 1 is 4. 4 over 2 is 2. I already have it. So what does this tell me? This tells me that these are the only possible numbers that could be rational roots. There is no other choice. Plus minus 1, plus minus 1/2, plus minus 2, or plus minus 4. There are eight choices. Now, what do we do with these numbers? Well, we do synthetic division to figure out which one is a good one. Now, which one should you choose? How do you know? Which of the 8 should you pick? Well, many times it's a matter of guess and check. Now, I'm going to pick one that I know works because for time. I will tell you when I did this problem, I didn't get the right one at first. I didn't. I am now because I've already done it. So I'm going to pick -2. That's the one I'm going to pick because I know it works. Did I do that at first? No, I certainly didn't. I think I picked one. What did I pick? I picked 1 first. 1 doesn't work. And I'll show you what I mean by doesn't work. So remember synthetic division, we put the possible root in the box, and then we lay out all the coefficients, 2, 7, 4, -4. Do we remember? Okay, dig back in your memories, ladies. What would I put? You're like, stop with the memory stuff. I've already remembered enough. Okay, what would I do if there wasn't a 7x squared there? What would I put in the place of this 7? Do we remember that? 0. I would put a 0 there. You cannot leave anything out. Make yourself a note. No missing terms. If you have a missing term, stick a 0 in. And there's one on your homework that's going to cause you to stick a bunch of zeros in there. So please be careful. Make yourself a note. No missing terms. In other words, I need to go from the 3rd power to the 2nd power to the 1st power to the 0 power. I don't have a choice. And if I'm missing any of those powers, I need to stick a 0 in. All right, here we go. Here's synthetic division. We bring the first number down. Then we multiply, add, multiply, add. I hope we remember. -2 times 2 is -4. Add down. 7 plus a -4 is 3. Okay, great. -2 times 3 is -6. Add down. 4 plus a -6 is -2. -2 times -2 is 4. Add down, and I get a 0. This is what tells me, this means, the 0 means that x equals -2 is a 0. That's what that 0 means. Yay, I found one. The remainder is 0. Remember, this is what I have highlighted in yellow is called the remainder. That is the remainder. Okay, then what do we do? Well, you could try another number, but when you try another number, you need to go back to this. Don't ever go back to the top. Just make yourself a note. If you're trying another number, use this. Use these numbers, use these for future numbers to test. Don't ever go back to the 274 negative 4. Okay, now I'm not going to keep doing P over Q because when I get down to a quadratic, I always translate it to a regular old equation. So I started with the cubic. I just took a 0 out of negative 2. Now I'm with the quadratic. So this is 2x squared plus 3x minus 2. And I set that equal to 0 and solve. If I can't factor, think back to solving quadratics last year. If I can't factor, what should I try? Too much memory all in one time? Quadratic formula. Quadratic formula. If I can't factor, I do quadratic formula. But this one, luckily, I can factor. It's 2x minus 1 and x plus 2. So I say 2x minus 1 is 0, x plus 2 is 0, and then I solve. So we got 1/2, we got negative 2. Oh, I already had negative 2. Okay, well, negative 2 showed up twice. That means that my answer is x minus 2. There's a multiplicity of 2, and x equals 1/2. How many zeros am I supposed to have? I'm supposed to have 3, because that power is 3. Do I have 3? Yep. I have 1, I have 2, and I have 3. I have 2 negative 2's and 1 1/2. I have 3 answers. And then we just found all the real zeros of p of x using rational roots theorem. Yay! Woo! Yes?
So for the negative 2's, you're getting one from factoring, and then the other one was like
the synthetic division. Yes, ma'am. That's exactly right. I got one from synthetic division, and I got one from factoring. I got them from 2 different places, which is okay. That's okay. But they're individual guys. Just because I got the same number twice doesn't mean that that's not an answer. Does that make sense? Because basically I have a duplicate answer, if you will. That's a duplicate means multiplicity of 2. That means I have 2 of them.
Why, so after you do the first synthetic division, why do you have to use those numbers for the future?
Oh, because if you go back to the original numbers, you'll never be done. Because that's a cubic. If you keep going back to the cubic, so what we want to do is we want to narrow it down like a funnel. So we want it to look like a funnel with maybe we have, 4th degree up here. So we have a bunch of, so this is x to the 4th. Then we narrow it down and we get x cubed. Then we narrow it down and we get x squared. And once we're in x squared, I ditch p over q and I go to quadratics.
Just because it's easier?
Yeah. Okay. Yeah. And actually you won't be able to finish the problem if there are irrational solutions that require you to use quadratic formula and you don't narrow it down like this, you will never get to the quadratic. Okay. So you'll never be able to use quadratic formula. So you really need to go with the new one every time when you get an actual answer. When the remainder is 0, you need to go with the new one every time. Okay?
But if the remainder is not 0,
then it's a fail and you got to keep trying. Yeah. Okay. Are we okay? All right. So the next one is factoring. Yay. factor p into linear and irreducible quadratic factors. I already explained what linear and irreducible quadratic means. So hopefully you have that written down. So factoring, if you forgot about factoring, you might want to go back and look at your notes from last year about factoring. We have a whole lesson on it with all kinds of instructions on what to do. This is called quadratic form. Quadratic form because this one, 4 is 2 times the exponent in front of it. It's 2 times the 2 is 4, and this is a constant. That's called quadratic form. And when we're in quadratic form, we can factor like FOIL to where x to the 4th is x squared times x squared. I need two numbers that multiply to get -8 and add to get 2, which gives me what, a +4 and a -2. Okay, this is an irreducible quadratic factor. What I have highlighted in pink is irreducible quadratic because, okay, so scratch work. I'll just do the scratch work out to the side. So scratch work. If I did x squared plus 4 equals 0, that would give me x squared is -4. So x is going to be plus or minus 2i. It's imaginary. That's why it's called irreducible quadratic, because if I kept going, I would get imaginary. So that one's done. So x squared plus 4 is part of the answer. X squared minus 2 is not irreducible. Is not irreducible. So let's keep our scratch work. So I've got x squared minus 2 is 0. X squared is 2. X is plus or minus the square root of 2. That's a real number. That's real. So I can factor this one into x plus root 2, x minus root 2, and I've done exactly what they've asked me to, which is factor into linear and irreducible quadratic factors. How are we doing? Okay. Part B asks us to go all the way into linear with complex. Complex means imaginary. So we're going to go all the way to imaginary. So I'm going to take my x squared plus 4, and we can see what happened up here with the x squared plus 4 right here. And that's going to factor to be x plus 2i, x minus 2i, and I've got my x plus root 2, x minus root 2, and I have done what they asked me to go all the way down to linear factors with imaginary coefficients. Whew. How are we doing? We're getting close. One more problem, and this last problem we're going to do on a calculator. It's a lot. I know, but like over half of it is review. Okay. Intermediate value theorem. Here we go. Last problem. Yay. Intermediate value theorem. So, first bullet. F of x is continuous from 1.7 to 1.8. How do I know that? Because it's a polynomial, and all polynomials are always continuous. I could wait to get my calculator and graph it if I wanted to look at it, but all polynomials are always continuous. Second bullet point. Well, to do the second bullet point, we need to find f of 1.7, and we need to find f of 1.8. We need to figure out if those are equal or not. And this is where I go to my calculator. Okay, are we okay so far? So we've established that the function is continuous. Now we need to find some function values. So here we go. Let's go to our calculator, go to our grapher. So we've got x to the fifth. Then we have minus 3x to the fourth. Then we've got minus 2x to the third. Then we've got plus 6x squared. Then we've got plus x, and then plus 2. Okay, let me look at this before I hit enter. So I got x to the fifth minus 3x to the fourth minus 2x cubed plus 6 plus x plus 2. Okay, looks good to me. Enter. All right, there it is. So what do I want? I need function values. So I'm going to, and we've done this before, just another reminder. I'm going to hit Control Doc to give me another page. And I'm going to hit calculator. Then I'm going to do var. I need f of 1, that's where it is, of 1.7. And enter. There we go, that's f of 1.7. Then I'm going to do f of 1.8. So var, f of 1, 1.8, enter. Are those the same y values? Nope. They sure aren't. So I'm going to go to my document. I'm going to write those down. Those are not the same y values. Here we go. Let's go back. So I'm going to write f of 1.7 was 0.3563 and f of 1.8 was negative 1.0211. So my second bullet point, f of 1.7 does not equal f of 1.8. Great, there's my second bullet point. My third one, they're telling us to approximate the zero, or they want to know that shows function as a zero. What does that mean? That means y equals 0, right? These are zeros, so y is 0. So in this case, k is 0. That's what it's saying. The y value is 0. Okay, so k is 0. So the third bullet point is 0 between f of 1.7 and f of 1.8. Is that true? Is 0 between 0.35 and negative 1? Is 0 in between those numbers? Yes, think about a number line. I know it's not a number line, but I mean think about numbers. 0 is between f of 1.7 and f of 1.8. That's our third check. Therefore, we're doing the conclusion. There exists a C between 1.7 and 1.8 for which f of C equals k, which is 0. There's our theorem. I'm going to pause there for a second. Okay, now it wants us to use our calculator to actually find that number, find the 0. The 0 that's between 1.7 and 1.8. So let's go to our calculator, go to our grapher. So here is, this looks like the 0 right here. That's between 1.7 and 1.8. So this is the one I need to find. We remember how to do that on our calculator, right? We do menu, analyze graph, zeros, and then I highlight it. So I want this one This is the 0 I want. And looky there, the 0 is at 1.7267. That's definitely between 1.7 and 1.8. So this is the actual C value. Okay, so that's 1.727. All right, so C, come back, little guy. So C equals 1.727. All right.